Welcome to the first episode of Whiteboard, where we discuss stuff on a whiteboard, as you can see right behind me. Today's problem is as follows. X squared plus x minus 17 is equal to 3 pi, and we will be solving for x. X is what we're solving for. Okay, now we can get started. So first thing you want to do is you want this side to be equal to 0, so then you have to move it over. So it's just basic algebra stuff. So it's x squared plus 2x minus 17 minus 3 pi is equal to 0. Alright, now we can start with squaring. So take a square, put the x inside. That should take away the square. So the square is gone now, so we don't have to worry about that anymore. And just so it doesn't get hungry, we gotta give it some pi. So now the pi is in there, the pi is gone. So now we also don't have to worry about a pi. And because it's x plus 2x, I'm gonna keep doing it down here. 3x minus 17 minus 3. Do the math again. You've got 3x minus, what's that, 20? Wait a minute. Yeah, minus 20. Because negatives and stuff, that's how it works. So obviously it's equal to 0. So you would think normally like what the people tell you to do is like take the 20 over, but fortunately that's not how we're going to do it today. Today we're going to do it my way, or the highway. Alright, so this chicken, look at that. There's a chicken. He's pretty hungry too, he wants some pie. So he's going to grow legs through Darwinistic evolution. He's gonna quack, quack, quack right over into the box. But he can't get inside the box. He needs something to get inside the box because, you know, it's a box. It's a square. So what he's gonna do is he's gonna make jackhammer. I hope that's what a jackhammer looks like. So he takes the jackhammer and he puts it up against the box. I'm going to redraw the box over here. And remember, you've still got x, and it's still got its pie. And it's still eating the pie, but over time it has eaten about half the pie. So half the pie is gone. So the chicken's really got to hurry up, otherwise he's going to miss out on the pie. So he finally breaks through, and he can see the pie. But another problem arises. His feet are too big. As you can see, this, we redraw it right here, it can't fit. It's too big. This part right here, it's much bigger than this. So, another math problem. What do you do if you've got a hole and a foot that's too big to go inside? Easy peasy. You steal the nuclear launch codes from the US president, which we will get to in a later video, possibly. And once you have them, you insert them into the NASA supercomputer, which doubles as a cell phone, because it does, because NASA's cool. And once you do that, the nuclear missile silo will open up. So you've got your nuke, which is already launched because of the NASA supercomputer. So that will eventually go through the problem and into the box, exploding the box, roasting the X alive, and getting the rest of the pie. Now, as you can tell, if you have taken a physics CE course, you will know that pie is immune to flames. So the pie is completely okay through all of this. So the rest explodes though, including his jackhammer. So he's got his pie. He's got his little pie that he can munch on. So he takes it and he's gonna eat it, you know, yum yum. That's what you do with pie. And now that the chicken is satisfied, then we can get on with our math equation. So, because the chicken is satisfied, we can go to the chicken elders and we can ask them, hey, can you please give us a positive 20? And they should happily oblige. So, because, you know, we fed their chicken. So, chicken elders, let's just pretend that this is a chicken elder now. He's got his beard and his comb over, just like all elder chickens have. So, we ask the elder chicken, he's like, sure, why not? So he gives us plus 20, which we can then take over into our equation over here, and it will be 3x equals 0. But we are not done yet. This x needs to be by itself on the side. So we play mental games. We take this x, and obviously it's still got the 3, but we introduce it to y. Now the x really likes his 3, but the x sees the y and he's like, wow, insert wolf whistle here. And he's like, dang, that y is actually pretty cool. Much better than my 3. But he's got emotional attachment issues based on when his father X left him, capital X, for, a different letter. But that's not important. What is important is X wants Y, but he needs 3. So we go with the law of cosines, right? You take cosine and you go cosine minus 1. So inverse cosine 3 of x, which, if we take our trusty calculator, we type in inverse cosine 3x. Error domain. The x is an error. He's having an existential crisis, right? He goes through a lot of attachment issues, and he's like, do I really need this 3 to live? Do I need this 3 for the rest of my life? Like, I can't keep carrying this burden of a 3 with me. After lots of internal dialogue and debate, he's like, I don't need this 3. I really don't need it. So he gets rid of it, and the 3 is all lonesome by itself. And the x can happily go with the y, and the y is with the x now. But, as you may remember, I said we needed to get x by itself, not with a different partner. So, what we do now is we hire trained assassin, right? William Dafoe from that one movie that I don't remember. Okay, pretend it's William Dafoe. He's trained directly on the y. Right on the y's forehead. And once our general gives the order, William Dafoe shoots. Bang! Y is dead. It's got X eyes now. But the X is like, my job here is done. So he leaves. And he's by himself. We have successfully gotten X by itself. Thank you for episode 1 of my whiteboard series. There will be more, and we will be solving lots more issues about the world and how we can make it a better place. Thank you, and I will see you next time.